Physics Part 27. The micrometer screw gauge is very likely to have a systematic zero error. Every time you use the gauge, you should check the zero error by moving face B so it makes contact with face A. The screw must be tightened with the regist C so that a producible zero is obtained. Then take the reading on the barrel and the thimble. This gives the zero error. It must be allowed for all in the subsequent readings. Well, the figure shows a screw gauge with a zero error of plus 0.12 mm. If this were the errors which applied when the reading of 9.86 mm was obtained in figure, the true length of the object would be 9.86 mm minus 0.12 mm, which is equal to 9.74 mm. Figure shows a zero error of minus 0.08 mm. In this case, the true length of the object in the figure would be 9.8 mm plus 0.08 mm, which is equal to 9.94. In the case of a wooden caustic meter rule, it is good practice to check the calibration against an engineer's steel rule. If one is available in your laboratory, it would be unusual to do the same with the micrometer screw gauge, but if there is doubt about the calibration of a particular gauge, it can be checked by measuring the dimensions of a series of gauge blocks. A gauge block is rectangular steel block with facts which are accurately plane and parallel. The length of the gauge block is known to an uncertainty of less than 1 mm. However, not many school laboratories possess gauge blocks. The vernier caliper. A vernier caliper is a versatile instrument for measuring the dimensions of an object, the diameter of a hole or the depth of a hole. Its range is up to about 100 millimeter, and it can be read 0.1 meter to 0.5 millimeter depending on the type of the vernier with which it is fitted. It consists of a steel millimeter scale with two reference posts at 0 mark in the figure. The figure shows vernier caliper, sliding vernier caliper scale from 0 to 30 millimeter and beyond, vernier caliper scale with regarding 25.4 millimeter, measurement of the depth of a blind hole. A sliding pot B moves along the scale. The slider is the vernier scale engraved on it. The zero of the vernier corresponds with reference post on the sliding pot. One set of the reference posts, those with the straight parts on the inside, is used like the jaws of a screw gauge. The object to be measured is placed between the jaws, and the sliding pot B is moved until the object is gripped tightly. A reading is to the nearest mm is taken on the fixed scale at 0 end of the vernier scale. The reading to 1/10 of a millimeter is obtained by finding where a graduation of the vernier scale coincides with the graduation of the fixed scale. Figure shows the scale of a vernier caliper giving reading 25.4 mm. The second set of the jaws has the straight parts on the outside. These can be used to measure the diameter of a hole. The jaws are placed inside the hole and are moved apart until they are in contact with the edges of the hole. The scale and the vernier can then be read. A pin that at the end of the sliding part of the caliper can be used to measure the depth of a hole. For example, a hole which has been drilled in but not right through the wooden board. The end of the fixed scale is placed on the board across the hole. and the pin moved into the hole until it reaches the bottom. The reading of the scale and the vernier gives the depth of the hole.